Hello everyone, myself Dashanas, studying in Sri Venkateswara College of Engineering, Bangalore. Today I am going to explain you about the probability distribution. Now we shall look into the contents. At first, it is introduction based on probability, examples of probability, probability distribution, formula based on partial differential equation, problem based on partial differential equations, types of probability distribution, binomial distribution, Poisson distribution, real-time examples of partial differential equations, random variable, types of random variables, and last it is the conclusion. Now, before moving on to the probability distribution, at first we shall come to know what is meant by probability. The probability of the event A is given by probability of the happening event is equal to m by n, where probability of the happening event is the probability of an event and m is the number of favorable outcomes, n is the total number of events in the sample space. That is, the probability of non-happening event is probability of non-happening event is equal to 1 minus m by n. That is, probability of non-happening event is equal to 1 minus probability of happening event. Now, there are two types of theorems in this probability, that is additional theorem of probability and second one is multiplication or product theorem of probability. Let's take a small example of probability. That is, when a card drawn from a pack of 52 cards, find the probability of getting subquotient A, king, subquotient B, king or a queen. Moving on to the solution, at first we shall take number of possible outcomes which is equal to 52, that will be n, and the number of favorable outcomes m, which is equal to 4. The probability of getting king which is equal to m by n, we shall be getting the answer as 52. Now, the number of favorable outcomes m which is equal to probability of king plus probability of queen. We shall take the examples, that is probability of king or a queen, because we won't be neither knowing it will be a king or a queen. So we shall take it as 4 plus 4 which will be equal to 8. So probability of getting a king or a queen which will be equal to m by n, that is 8 by 52. We shall be getting the answer as 2 by 30. Moving on to the main topic, that is the probability distribution. The probability distribution of a random variable x shows how the probability of the events are distributed over different values of the random variable. When all the values of the random variable are aligned on a graph, the values of the probabilities generate a shape. That is, the probability distribution has several properties. That is, for example, expected values and variance that can be measured. It should be kept in mind that the probability of favorable outcome is always greater than the zero and the sum of all the properties of all the events will be equal to 1. Let us see some formulas on probability distribution. There are three types of formulas on probability distribution. That is, first one is mean mu, which is equal to summation of x into p of x, where variance v will be equal to summation of x minus mu the whole square into p of x. At last, the third formula is standard deviation omega, which will be equal to square root of summation x minus mu the whole square into p of. If for each values xi of discrete random variable x being assigned a real number p of xi such that p of xi will be lesser than or equal to 0, summation of p xi will be equal to 1, then the function p of x is called probability function. Therefore, the set of values xi p of xi is called a discrete probability distribution of discrete random variable x. That is, the function p of x is called the probability density function. Now, let us speak few words on the problems on probability distribution. The probability distribution of random variable x is given below. So, find the value of k and the mean of variance of x. At first, we will be having x is equal to xi and p of x is equal to xi. The values of x will be equal to 1, 2, 3 and 5. The values of p of xi is equal to k to 5k. In order to fetch the mean value, At first, we will be multiplying the value of x and p of x. That is, 1 into k will be equal to k, and 2 into 2k will be equal to 4k, 3 into 3 will be equal to 9k, and 4 into 4 will be equal to 16k, and 5 into 5 will be equal to 25k. Now, the summation of x will be equal to 55k. Now, substituting the multiplying the value with 55 into 151, we will be getting as 3.6. In order to find the variance, we shall be multiplying the value of x into p of x. That is, k into k will be equal to k, 2 into 4k will be equal to 8k, 3k into 9k will give 27k, 4k into 16k will be equal to 64k, 5 into 25k will be equal to 125. That is summation of mu square minus x square into p of x, that will give 225k into 225, which will be equal to 151, and the given answer will be equal to 15. We also know that summation of p of x, that will be equal to 1. Therefore, k plus 2k plus 3k plus 4k plus 5k will be equal to 1. We will get the k as 151. Thus, the value of k, which is equal to 151, the mean of a given data mu, that is equal to summation of x into p of x, that is equal to 3.66, and the variance of a given data will be equal to summation of mu square minus x square, that is p of x, that is equal to 1.6. Then the mean and the variance of the given data is 3.66 and 1.6 respectively. Now, moving on to the types of probability distribution, there are five types of probability distribution. First is normal distribution, second is uniform distribution, third is binomial distribution, fourth is Poisson distribution, and at last that is exponential distribution. Now, moving on to the Poisson's distributions. A Poisson distribution is a discrete probability distribution, meaning that is gives the probability of a discrete, that is countable outcome. For Poisson distribution, the discrete outcome is the number of times an event occurs, represented by k. You can use a Poisson distribution to predict or explain the number of events occurring within a given interval of time. That is, the events could be anything from disease causes a customer purchases to the meteor strikes. The interval can be any specific amount of time or space, such as 10 days or 5 square inches. The formula of the probability x is equal to m to the power x into e to the power minus m by x factorial. Real-time examples for probability distribution. Probability distribution are used in many sectors. Here is some of the examples where the concepts of probability distribution are used in real time. First, to describe the population of real-life variable. Second, to score in a class or on a standardized test. Third, weight of an adult individuals in a population. Fourth, blood pressure in a population. Fifth, internet download speed. At sixth, birth weight of newborn babies. Seventh, finding the success and failures. Eighth, batting average in the basketball, and etc. Moving on to the random variable, let us come to know what is meant by a random variable. If a real variable x is associated with outcomes of random experiment, then is called a random variable or stochastic or variate. Random variable is a real valued function whose domain is the simple space of the random variable experiment. It is represented as x sample space, that is equal to a real number. Random variables are usually denoted by x, y, and z, and it may be noted that different random variables may be associated with sample space as the set of all real numbers of random variable x is called as range of x. Variable. Suppose a coin is tossed twice, some of the random variables can be defined as subquestion A, x is equal to number of heads in outcomes, subquestion B, number of tails in outcomes, subquestion C, z is equal to number of two consecutive heads. To find the number of random experiment of all the three cases, by solving we will be getting the solutions of all the three random variables. Moving on to the types of random variables, there are two types of random variables. First is discrete random variable and the second is continuous random variable. At first, we'll be speaking about the discrete random variables in the probability distribution. A discrete random variable can only take finite number of values. To further understand this, let's see some examples of discrete random variables. Subquestion 1, x is equal to sum of outcomes when two dice are rolled. Here x can only take values like 2, 3, 4, 5, 6, up to 10, 11, 12. And now the subquotient 2 that is equal to x, which is equal to number of heads in 100 coin tosses. Here x can take only the integer values from 0 to 100. Random variables in the probability distribution. At first, a continuous random variable can take infinite values in a continuous domain. Let's see an example of a dart game. Suppose we have a dart game in which we throw a dirt where the dirt can fall anywhere between -1, 1 on x-axis. So if we define our random variable as the x coordinate of the position of the dart, x can take anywhere from the value from -1, 1. There are infinitely many possible values that x can take, that is the x it will be equal to 0.1, 0.001, 0.01, 1, 2, 2.112 and so on. The last part, that is the conclusion of the probability distribution. That is the probability of a probability distribution are crucial element concepts in probability. You are now familiar with the name and shape of common probability distribution. We have found that the structure of any type of probability distribution vary according to the features of random variable distributions like discrete or continuous. Like and subscribe to the channel.